I can honestly say I never had a beer in my life.
I think of it as almost like a masking agent.
Because of the structure of alcohol, it is what's called both water soluble and fat soluble. What that means is when you drink alcohol, it can pass into all the cells and tissues of your body. It has no trouble just passing right into those cells. And the fact that it can pass into so many organs and cells so easily is really what explains its damaging effects. Ethanol produces substantial damage to cells. And it does that because when you ingest ethanol, it has to be converted into something else because it is toxic to the body. NAD and related biochemical pathways are involved in converting that ethanol into something called acetaldehyde. It's broken down into acetaldehyde. And if you thought ethanol was bad, acetaldehyde is particularly bad. Acetaldehyde is poison. It will kill cells. It damages and kills cells, and it is indiscriminate as to which cells it damages and kills. Now, that's a problem, obviously, and the body deals with that problem by using another component of the NAD biochemical pathway to convert acetaldehyde into something called acetate. Acetate is actually something that your body can use as fuel. And that process of going from ethanol to acetaldehyde to acetate does involve the production of a toxic molecule, right? Again, acetaldehyde is really toxic. What that means is that if your body can't do this conversion of ethanol to acetaldehyde to acetate fast enough, well, acetaldehyde will build up in your body and cause more damage. So it's important that your body be able to do this conversion very quickly. Cells within the liver are very good at this conversion process, but they are cells and they are exposed to the acetaldehyde in the conversion process. And so cells within the liver really take a beating in the alcohol metabolism events. And the reason why alcohol is considered empty calories is because that entire process is very metabolically costly, but there's no real nutritive value of the calories that it creates. You can use it for immediate energy, but it can't be stored in any kind of meaningful or beneficial way. It doesn't provide any vitamins. It doesn't provide any amino acids. It doesn't provide any fatty acids. It's truly empty calories. Now, the important thing to understand is that it is the poison, the acetaldehyde itself, that leads to the effect of being inebriated or drunk. I think most people don't realize that being drunk is actually a poison-induced disruption in the way that your neural circuits work. And some amount of acetaldehyde and acetate are making it into the brain. It crosses the blood-brain barrier. The brain has this fence around it that we call the blood-brain barrier, or the BBB. Many things, most things, thankfully, can't pass across the blood-brain barrier, but alcohol, because it's water and fat soluble, just cruises right across this fence and into the milieu, the environment of the brain, which is made up of a couple different major cell types: neurons, nerve cells, and so-called glial cells, which are in between the nerve cells. So what happens when alcohol gets into the brain that makes us feel tipsy or drunk, and in some people makes people feel really especially energized and happy? Well, alcohol is indiscriminate in terms of which brain areas it goes to, but it does seem to have a propensity or an affinity for particular brain areas that are involved in certain kinds of thinking and behavior. So one of the first things that happens is that there's a slight suppression in the activity of neurons in the prefrontal cortex. This is an area of your neocortex that's involved in thinking and planning, and perhaps above all, in suppression of impulsive behavior. So if you go to a party and they're serving alcohol and people are consuming drinks, what you'll notice is that a few minutes into that party, the volume of people's voices will increase. And that's because people are simply not paying attention to their voice modulation. As other people start speaking more loudly, other people are speaking more loudly, because as the prefrontal cortex shuts down, people stop modulating their level of speech quite as much. Also notice that people start gesticulating more. People will start standing up and sitting down more. They'll start walking around more. If there's music on, people might spontaneously start dancing. As you shut down the prefrontal cortex, people will say things that they want to say without so much forethought about what they're saying. Or they might do things that they want to do without really thinking it through quite as much, or they might not even remember thinking it through at all or experience. Alcohol has a very strong effect in suppressing the neural networks that are involved in memory formation and storage. This is why oftentimes we forget the events of a night out if we've been drinking. One of the more important things to know about the effects of alcohol in the brain is that areas of the brain that are involved in flexible behavior, sort of considering different options, like I could do A or I could do B. I could say this to them or I could say that. I could say it in that way or I could say it in this way. This might be a little more tactful. Those brain areas basically shut down entirely, and people just tend to say what they want to say. Fortunately, it is reversible. So in animals or humans that undertake a period of abstinence of anywhere from 2 to 6 months, these neural circuits return to normal, except in cases where people have been chronically drinking large volumes of alcohol for many, many years. And in those cases, while there is some recovery of brain circuitry after people get sober, meaning completely sober, they stop drinking entirely, there is evidence of long-lasting impact of heavy alcohol usage throughout the lifespan. But of course, this doesn't mean that anyone that's suffering from alcoholism or that used to should not continue to focus on their health. You absolutely should. All is not lost. But for people that have been drinking for a lot of years, maybe you went to college and you drank a lot in those years and your neural circuits change. If there's a period in which you don't drink alcohol, again, from 2 to 6 months and ideally longer, those neural circuits can then be remodified back to their original state. One also very interesting finding is that alcohol changes the relationship between what's called the hypothalamus and the pituitary gland and the adrenals. Now, the hypothalamus is a small collection of neurons about the size of a large gumball that sits above the roof of your mouth, and it houses neurons that are responsible for some incredible aspects of our behavior and our mindset. Things like rage, things like sex drive, things like temperature regulation, very primitive functions, including appetite, thirst, etc. So the hypothalamic pituitary adrenal axis, I know that's a mouthful. You don't need to remember the names, but the hypothalamic pituitary adrenal axis maintains your physiological balance of what you perceive as stressful and what you don't perceive as stressful. People who drink regularly experience increases in cortisol release from their adrenal glands when they are not drinking. And as a consequence, they feel more stressed and more anxiety when they aren't drinking. So, I mean, how many times have we heard somebody say, oh, I need a drink, and then they have a drink and they're like, calm down. Now they can shake off the thoughts about the day's work. They can start to think about things in a maybe more grounded or rational way, or at least they believe that, or they can somehow just relax themselves. Well, while that very well may be true, that it can relax them, when they are not drinking, that level of cortisol that's released at baseline has increased substantially. If people are ingesting alcohol chronically, even if it's not every night, there are well-recognized changes in neural circuits, there are well-recognized changes in neurochemistry within the brain, and there are well-recognized changes in the brain-to-body stress system that generally point in 3 directions. Increased stress when people are not drinking, diminished mood and feelings of well-being when people are not drinking, and changes in the neural circuitry that cause people to want to drink even more in order to get just back to baseline or the place that they were in terms of their stress modulation and in terms of their feelings of mood before they ever started drinking in the first place. Very clear that those sorts of drinking patterns are changing neural circuitry and they're changing hormone circuitry. And I'd love to be able to tell you that they're changing them for the better, but they simply are not. They're actually changing them for the worse. And worse is defined as making people less resilient to stress, higher levels of baseline stress, and lower mood overall.